Poisson ratio has always been defined as a ratio of lateral to longitudinal strain. Now let's dig deeper and get more valuable insight on this particular topic. Take a piece of eraser and try to pull and push it. It will be evident from this experiment that the dimensions of the rubber before the process and during the process are not one and the same. There is a variation in the lateral and longitudinal dimension. They elongate or compress depending on the force you apply. Simple, right? In layman's term, Poisson ratio expresses the changes that happen in this eraser when a force is applied on it, and this change happens along and opposite to the direction of force applied. The range of this ratio is -1 to +0.5. So from this range, you can note that we have a positive, 0 and a negative Poisson. Let's take an example to understand the positive Poisson. Let's take a tube fitted to a pipe. When you try to pull the tube by applying force downwards, it becomes difficult to remove the tube. This is basically because of Poisson ratio. When there is a longitudinal pull in the downwards direction, the lateral dimension of the tube reduces than normal and it firmly holds on to the pipe, and it is thus becoming very much difficult to remove the tube. So what do we do next is to hold on to the pipe and then again apply longitudinal pull. Only then the tube gets removed. So this type of a positive behavior is seen in steel, concrete, aluminium and many other materials. Now let's look at the next thing. There are few materials which has a 0 Poisson ratio. So what does that mean? Whatever the longitudinal force you apply, there isn't going to be any lateral strain. Okay, so let's take an example of a rubber cork. Rubber is a positive Poisson material and you are using it to close a glass bottle. When you try to push the cork from upwards, the cork will have a lateral strain and expand, thereby applying a force on the glass bottle, which may be the reason to break it. But on the other hand, the wooden cork, a 0 Poisson material, will not exert any lateral strain to the glass bottle, thereby it saves it from damages. The last topic we have in here is a negative Poisson. Do you know there are materials which exhibit a unique characteristic wherein when you stretch along the longitudinal direction, the material expands in the lateral direction, and when you compress them, the other direction also compresses. This is exactly an opposite phenomena of positive Poisson. This characteristic is naturally present in the Achilles tendon of humans and animals. While stretching, the bone thickens and vice versa happens. Mainly, this reduces the impact on the body. Now, this principle has been followed in a variety of fields like in sports to reduce the impact on the body of wrestlers and athletes. Wrestling mat and running track mats are replaced with negative Poisson materials. To have much more learning and understanding about civil engineering, especially about steel design, visit our website, link in description.